Bismillah Rahmani Rahim.
You are tasked with designing a carburization process for gears of 0.5% carbon steel. The resulting gears will have 0.8% carbon at depth of 7 millimeters into the surface. If you can produce an environment of 3.5% carbon and hold a temperature of 1200 degrees Celsius, how long will this process take? Carbon to iron, D naught, or the coefficient of diffusion of this process, is 0.25 centimeters cubed over second, and our activation energy, or Q, equals to 32,900 calories per mole. So, the problem that we were given was a carburization problem, which is one of the problems that probably tricks people a lot up, because it used a lot of tricks and stuff that we probably were not very familiar in engineering, at least, and somewhat we weren't very interested to it, even in chemistry when we talk about this. So, we have been given this whole problem, this whole given, and it's like, oh my god, what we're supposed to find. So, one of the things I learned from my back days when I was doing stuff, I obviously when I was going to the SI and solving the problems, and thanks to the SI that I had, Reed Harper. Oh my god, why you want to play today with me? Okay. I will say your best shot is create a given and find table. So we're gonna say, okay, what was our given when we started this question? Oh my god, are you kidding me? Alright, it's fine. Alright, so we create a given and find table. And we said, okay, what we have been given on this question? We have been given CS, CX, C naught, D naught, X, T, Q, and R. Now I'm going to explain what all of those mean. And what we have to find, we have to find the diffusivity D and time, which our final goal is finding time. This is the carburization formula, which is CS minus CX over CS minus C naught. And this value should give us an error function, or error function. That's when we wait error function. We're just speaking too loud. Error function of x over 2 times square root of diffusivity times time. Now, we check. We have CS, we have CS, we have CX, we have C naught. So we have all the values that we have for the value. What is it? Well, that means we probably don't have all the values that we need for the argument, because we do have x, and diffusivity, if we solve for it, we kind of do have diffusivity, but we don't have time. So basically the question wants us to solve for time. Now, how do you solve out trying to get to this problem? So the first thing is we're going to identify what are our CS, CX, and C naught. Usually the bigger value in the question is the CS. So 3.5% that we had is our CS. The middle value will be CX, which is 0.8%. And our C naught will be the lower value that you have in a question, which is 0.5% in this one, percent carbon. So we're going to put all of these values in to the value part of our formula. This will give us the calculation below, which you have 3.5 minus 0.8 over 2.5 minus 0.5, which is 2.7 over 2, and you get 1.35. So this 1.35 is equal to the error function of x over 3 times square root of dt. Now, in order to find out what is inside here, we have to use interpolation. Oh my god, my bad. You have to use interpolation. So, let's go ahead and use and see how we can solve this problem as an interpolation. Now that we have these values and argument, now you can put it as an error function. Now I use the real error function because we have a real table, but usually in exams and other stuff, they're gonna give you not the real error function, table, so you have to probably like go and figure it out and do stuff. And this leads us to this part. So now that we do have the values inside and the stuff that we need, we're gonna compare this to the argument. So the 1.35 lies between 1 and 1.50 in the table. I have 0.8427 and 0.9661, and we're gonna say, okay, this value is Rosalina's crown. For some reason, I'm very dedicated to like Rosalina in Mario, so I don't know, you guys probably can ask me why I like Rosalina. There's weird debates on her, but hey, I'm gonna use the crown, man. This is Rosalina's crown. Then you have to find an argument. Or I can even say this is a star. I mean, that's the easiest part, but I just want to do something different. Alright, so we're gonna put this, and what we have is in one side, doesn't matter which side you choose. You have to have the 1.50 minus, oh shoot, this is erasing. 1.50 minus 1, and that is 1.50 minus the value that you're getting between these two, and then 1.50 minus 1. In the same manner, you have to 0.9661 minus the crown, and that will be then again 0.9661 minus the initial amount 0.8427. You get something calculation like this. So you get one side, as I talked to you about, on the value side, and we have the argument side which you have to solve for the crown. Now I get 0.15 over 0.50, and as be 0.9661 minus the crown over 0.1234. Which is weird, I have 0.1234. That's actually something I didn't want to get, and it's very funny. I actually got that. Alright, so we're going to continue on by solving this because I didn't have any space. So I know 0.15 over 0.50, that's 0.3 equals to the 0.9661 minus the crown over 0.1234. Now both sides times by 0.12. This is just basically algebra at this point. 0.1234, and this side by 0.1234. So you get the crown. Oh shoot. You get the crown, and by the thing I'm doing, I'm actually switching sides right now. So 0.9661 minus that value, and let's say whatever value that we multiply goes the other side. So we are going to find out what that is in a second. 0.3 times 0.1234, you get 0.037, and let's say we're gonna, this is gonna be minus the value because we put it on the other side. So because we switch places, it differs. So I'm gonna add both sides by 1 and 661.0.9661, and this will give me the value for crown, which will be minus 0.9. Alright, and that will give me 0.9290, or 9291. Now if I look at the value, we had 0.961 and 0.8 something. So this is going to be between those values, which makes sense because 1.35 is kind of down in the middle, a little bit very close to okay, so yeah, sorry, I just got a message, that's what it is. But this value is going to be our crown. Now we're going to use this value to go to the argument, to the argument side, and plug that in to find out time. Now we are not really into solving right now for time, as I thought we met, and I made this mistake, so very sorry about that one. But we know the crown is equal to x over 2 times the square root of the vicinity times time. So you're gonna, I say generally, except of putting numbers in first, is very best that if you not put the numbers first and decide to solve for the value itself. So basically you have 2 crowns equals to x over square root of dt, and then you solve for time, which you get x over 2t squared all over diffusivity. And now you know x is 0.7 centimeters because we had a millimeter, so we're going to do unit conversion. I'm going to solve for diffusivity, and then from there, when I know what the diffusivity is, because now I know the x and crown, then I can solve for time. Now, we know the crown value, and we know the value for x in centimeters. And this is the reason we make it in centimeters, because this value is in centimeters. So, the diffusivity value is d naught times the e to the power negative q, or the activation energy that we have, over the r value that we have, which is a constant, and temperature. So, we know that d naught from the question was 0.25 centimeters cubed over second. We do have to convert our temperature, because our temperature was 1200 degrees Celsius. And we need to add 273 Kelvin to get 1473 Kelvin. By doing so, now we know that the whole equation, which is a little very messy, sorry because I read right big, we have negative 32,900 calories per mole over 1.987 calories per mole times 1473 Kelvin. Now when I multiply these two together, I get 2926.851. That's the value I'm getting. And then when I get the value of my activation energy and divide by this value, I get negative 11.24. When I take the e to the power of that value, I get 1.31 times 10 to negative 5. And remember, because we have calories per mole and calories per mole times Kelvin and Kelvin here, all of these units cancel each other out. So all you have is a unitless value. Now that value, 1.31 times 10 to negative 5, is getting multiplied by 0.25 centimeters squared over seconds, which give you a d value of 3.28 times 10 to negative 6 centimeters squared over seconds. Now that we know the diffusivity and x, and we also know the crown value, now let's go ahead and solve this problem for t and see how long it will take, and we can finally solve this carburization process. So now, let me put the value again. My calculation is right, but I get a very huge number, which might not make sense, but my calculation makes sense. So I have the 0.7 centimeters over the 0.9291, which is unitless, and we squared that to get a centimeters squared. Now that value inside will be 0.7534, but when I square it, I get 0.5676 centimeters squared. And that value doesn't change because they don't do anything. We divide, so centimeters squared goes away. We have only seconds now remaining. So you get something which I don't think that's little bit not reasonable. I don't know, because maybe I play with the numbers. But I get 173,000, 173,048 seconds. We're gonna convert this to hours, because whenever they usually ask you this, they want it in hours and minutes. So you get seconds and seconds go away, divide by 3,600, and you get 48.07 hours. Which, if you do it in hours and minutes, becomes 48 hours and 2 minutes. 2 days and 2 minutes, but honestly, that's how I get it, and my calculation was right. So hopefully you guys learned something new. There is another way to do this carburization process, but by doing the reverse method, which means you have the time, the diffusivity, and the x value, which means you have the argument. You solve for the argument, you find the value inside what is the arrow function, and inside that parenthesis. Now you have to enter and do the interpolation to get to the value, and then do the maybe they ask you for CX, maybe C0, maybe CS. So you will find out what value you'll be getting, and you solve it out. So there's two ways to do this. I'll do the other one, but I don't really have time at this moment, so I just did this process. Hopefully there's something new, and if there's any questions, let me know that in the comments.